Hello people, Virus here today, and we're gonna be looking at another physics lesson. This time we're gonna be looking at series circuits. So let's jump into it.
It was a nightmare.
Activate.
Series circuits. So the first learning objective is to understand how current, potential difference, and resistance for each component in the circuit. In a series circuit, the same current passes through each one of the components, okay? And the total potential difference of the power supply is shared between the components. So in this first diagram, if the power supply is 5 volts, 5 volts are gonna go through that one light bulb. Now in the other diagram, when the power supply is 5 volts, but there is more than one light bulb, that power supply is gonna be divided, that potential difference is going to be divided between the two components in that series circuit. In this case, the two light bulbs, one of them will have 2 volts and the other one will have 3 volts, and therefore the light in this first light bulb over here in the 3 volts is going to be slightly brighter than the light in the second bulb that only has 2 volts. Okay, so task number 1. If the potential difference of a cell is 1.2 volts and the potential difference across one light bulb is 0.8 volts, work out the potential difference across the other light bulb. That will be 2 marks. So as always, you can pause the video and then get back to your answer. Right, so as we can see here, the potential difference of the second light bulb would be just 0.8 from the first light bulb, taken away from 1.2 from the total potential difference in the cell, and that will give us the answer, which is 0.4, and that is the voltage or potential difference going through the second light bulb over here. Learning objective number 2. Understand potential difference of several cells in series. The potential difference of a cell in series is the sum of all the potential differences of each cell. So in this case, in this diagram, we have one cell, another cell, and another cell. Say for instance, we got 3 batteries, one after the other in this circuit. Now, the total potential difference of the whole cell will be 4.5 because we add in 1.5, 1.5, and 1.5. So the total potential difference is 4.5. And as always, it will be divided through the components in the series circuit. So in this case, we have 2 light bulbs. One light bulb will have 2.5 volts and the other light bulb will have 2 volts. And as always, because this one has a higher voltage in there, it will be slightly brighter than the one with 2 volts. And the current going through both of those components is still going to be the same. Now, task number 2. Find the missing values for the following series circuits. You got 6 marks. As always, you can press pause and we can get back to the answers. Okay, so as we can see here, the total potential difference was 9, so it must mean that each one of those cells is 3 volts each. And as we go and follow the current, we see that the first light will have 6 volts. So if you take away 6 from 9, will give you 3, so that's why the second bulb has 3 volts on it. As always, the one with the most voltage will be the light bulb that is the brightest. And over here we can see that we have 3 cells, 2.5, 2.5, and 2.5. all together they make 7.5. So the total potential difference in this circuit will be 7.5. If one of the light bulbs had 2.5 volts, it means that the first light bulb would have 5 volts going on to it, because if you take away 2.5 from the total amount, which is 7.5, that gives us 5 volts, and that's why this here is 5 volts. Learning objective number 3. To understand how to calculate the total resistance of 2 resistors and know why adding resistors in series increases the total resistance. The total resistance of 2 or more components in series is equal to the sum of the resistance of each component. So the total resistance that we're gonna have in this whole series circuit is the resistance from the light bulb and the resistance from the variable resistors added together, okay? And that's what is gonna give us the total resistance. Now, if we have resistance number 1 and resistance number 2, we add them both together and we get the resistance of the whole series circuit, okay? Task number 3. Use the information in the table to calculate the resistance of the filament lamp and the variable resistor when the filament lamp is normal, dim, and very dim, assuming that the current is 0.1 amps. You get 9 marks for this, and as always, you can pause the video and we can get back to the answers afterwards, okay? So, as you can see, you could have used this formula right here that tells you that resistance equals to potential difference divided by current. Now, when the light bulb is normal, the potential difference is 1.5 volts. Okay, so the potential difference will be 1.5 volts, and we said that assuming that the current is 0.1 amps, it would have been divided by 0.1, and that's why you got 15. When you apply this formula and you add those values into the formula, you will get the following. The filament lamp resistance will be 15 when normal, 9 when dim, and 5 when very dim. And we're looking at the resistor. When the light bulb is normal, the resistance is 15. Is 0, and when the light bulb is dim, the resistor is 6. When the light is very dim, the resistor is 10. So altogether, when we add those, the total resistance of each one of those examples, when the light is normal, filament 15, variable resistor 0, so the total is 15. So it always is gonna add up to the total resistance on the actual circuit. It just depends whether the light bulb is a normal brightness, is dim, or is very dim. Question number 4. A 1.5 cell is connected to a 3 ohms resistor and a 2 ohm in series with each other. Draw a circuit diagram for this arrangement, calculate the total resistance of the 2 resistors, and calculate the total current through the resistors. As always, you can pause the video and you can get back to the answers. Right, so in the answers over here, we said that we had to draw a diagram with the actual circuit. So if you got that the potential difference was 1.5, that would have been the energy over here coming from the battery. The first resistor is 0.3 and the second resistor will be 2.0. Now the reason why we put this one here first and that one second is because the first component is always going to get more potential difference, therefore it's going to have a lot more resistance than the second one over here, assuming that they're both the same components. It's just done twice. Right, so next answer we got here is 3 ohms from resistor 1, 2 ohms from resistor 2. The total resistance is actually 5. That's your answer for B. And to calculate the total current through the resistor, so current equals to potential difference divided by resistance. So the total potential difference is 1.5, the total resistance is 5, so your current is 3 amps. Okay, so that was a very short video. Hope you understood this. As always, you can drop your comments at the bottom if you didn't understand something. Maybe I can get back to you, but see you in the next time. And remember, knowledge is power. Like and subscribe.